At 7:45 a.m. on February 21, 1945, a stream of liquid fire erupted from a Sherman tank and poured directly into a Japanese bunker, and within 5 seconds, 11 days of killing stopped cold. No artillery had done it. No infantry charge had done it. A 24-year-old Navy electrician from Hawaii did it. His name was Joseph Kissle. He was not a general. He was not a hero in any official sense. He was an electrician's mate second class who spent his days crawling inside tank hulls, soldering wires and testing circuits. And on that volcanic island in the middle of the Pacific, the weapon he built with his own hands, the weapon the Army called insane, the weapon the Marine Corps had never trusted destroyed in 5 seconds what had taken an entire Marine division 2 days and 15 dead men to fail at. By the time the battle for Iwo Jima ended, 36 days later, that weapon had conducted over 240 missions, destroyed 370 fortified positions, and helped reduce Marine casualties by 42% in every sector it operated. 5th Marine Division would later state officially, and on the record, that Kissle's flame tank was the most important single weapon available to the division. Don't forget to hit like, subscribe, and turn on notifications so you never miss our next video. Join us as we explore more stories, historical events, and inspiring moments from the past. Be part of a community that keeps history alive. But before any of that happened, before the fire, before the victory, before the Marine commanders begged for more, there was a problem so brutal, so mathematically cruel, that the men sent to solve it were essentially being handed death sentences. And nobody had an answer, until one man did. And everyone thought he was out of his mind. Here is where the story really begins. February 1945. The United States Marine Corps had been fighting across the Pacific for 3 years. Island by island, reef by reef. The Japanese had demonstrated one absolute truth. They did not retreat. They did not surrender, and they built fortifications that conventional weapons could not destroy. By early 1945, American military planners were staring at casualty projections that were genuinely terrifying. The invasion of Japan itself was being estimated at 1 million American dead. Every island before it was a preview of that nightmare. Iwo Jima was 8 square miles of volcanic rock, sulfur sand, and underground death. Japanese General Tadamichi Kuribayashi had spent months engineering the island into a fortress, unlike anything American forces had encountered. 11 miles of tunnels connected 750 fortified positions, concrete pillboxes, reinforced caves, steel-doored bunkers buried so deep that naval bombardment did essentially nothing. American ships fired 22,000 shells into that island before the landing. When the Marines came ashore on February 19, 1945, they discovered the bombardment had destroyed almost nothing. The Japanese had simply waited underground, and then they came up and started killing. 70,000 Marines landed on black volcanic beaches. 22,000 Japanese defenders waited for them. The first day alone produced 2,400 American casualties. Marine units advancing inland ran into a wall of interlocking fire from positions they could not see, could not reach, and could not destroy. Artillery bounced off 3-foot-thick concrete. Small arms fire was useless against steel doors. Tanks were ambushed from hidden positions. The mathematics of the assault were horrifying and simple every time Marines tried to advance Japanese machine guns in fortified bunkers, cut them apart. The official solution, the weapon the Marine Corps had assigned for destroying fortified positions, was the portable flamethrower. The M2 flamethrower. A backpack system carrying 100 pounds of pressurized fuel with approximately 7 seconds of total burn time and a range of roughly 40 yards. In theory, it was effective. In practice on Iwo Jima, it was a death sentence. Japanese snipers identified flamethrower operators the moment they stood up, because the twin fuel tanks on their backs were visible from 300 yards. The operators never reached their targets. One Marine battalion using portable flamethrowers recorded a 92% casualty rate. 92%. That is not a combat loss. That is annihilation. Senior officers knew the portable flamethrower was failing. They knew men were dying, not because the weapon didn't work, but because the men carrying it were being shot before they could use it. The problem was not firepower. The problem was exposure. Every solution they had tried required a human body to be within sniper range of a Japanese position, and the Japanese were extraordinarily good at killing human bodies. No one in the standard chain of command had a workable answer. The situation was locked, and it might have stayed locked hundreds more. Marines might have died in those same futile charges if it were not for a decision made 8 months earlier at Schofield Barracks in Hawaii by a colonel who was willing to listen to an idea that most of his colleagues considered dangerously absurd. This is where Joseph Kissle enters the story. Kissle was born in 1920. He grew up working with his hands, the kind of young man who understood machinery intuitively, who could look at a circuit diagram and immediately see not just what it was designed to do, but where it would fail. He joined the Navy as an electrician's mate and was eventually assigned to the 117th Naval Construction Battalion, the Seabees in Hawaii. The Seabees were the construction and engineering arm of the Navy, the men who built airstrips under fire, who laid roads through jungles, who solved impossible logistical problems with whatever materials happened to be available. They were builders, problem solvers. And Kissle was one of the best electrical minds in his unit. In May 1944, Colonel Unmacht of the Chemical Warfare Service assembled a composite unit at Schofield Barracks that included 25 Seabees from the 117th Army Chemical Specialists and Marine tank crews. The mission was classified. The idea was simple to describe and nearly impossible to execute. Take the portable flamethrower with its 7 seconds of fuel and its 92% casualty rate and mount it on a Sherman tank. Put armor around the operator. Extend the range. Give the weapon protection that the human body could not provide. The idea had been attempted before, badly. The Army had created something called the Satan tank, an M3 Stuart light tank with a Canadian Ronson flamethrower system mounted on it. The problems were severe. The M3 Stuart had thin armor that Japanese anti-tank weapons penetrated easily. The Ronson system had limited range, questionable reliability, and insufficient fuel capacity. The Satan tank had been used in earlier Pacific campaigns, with mixed results and significant losses. It was not the answer. Unmact's team decided to go larger. 8 M4A3. Sherman medium tanks, heavier armor, more reliable engines, better crew protection. The challenge was designing a flame system powerful enough to be decisive, reliable enough to function in combat conditions, and integrated tightly enough into the tank that it could be operated and maintained in the field. That challenge fell largely to Kissle and machinist's mate First Class Reich. What they designed was designated the CBH-1. Installing it required 150 pounds of welding rod and over 1,000 individual electrical connections. The system operated at 300 pounds per square inch of pressure, launching burning napalm mixture 400 feet from the tank with 270 degrees of lateral traverse. The fuel capacity was 290 gallons compared to the roughly 4 gallons carried by a portable flamethrower operator. Range 400 feet. Portable flamethrower range 40 yards under ideal conditions. 0 yards if the operator was shot first. Every wire in the CBH-1 was run by Kissle personally. Every connection was tested by Kissle personally. He understood in a way that perhaps only a man who has spent months building something with his own hands can understand that a single failed connection in combat meant Marines would die. He tested the ignition system, a waterproofed cylinder housing matches that rotated like a revolver 40 times at Schofield Barracks. 40 times. It never failed once. When the Army officially reviewed the design, the response was skepticism, bordering on open hostility. Engineers who had not built the system argued that it was too complex for field maintenance. Officers who had not tested it argued that the fuel system was a fire hazard. Commanders who had not seen it operate argued that mounting a flamethrower on a Sherman would compromise the tank's primary function and make it a target. The word that circulated in certain Army planning documents was essentially that the whole project was an expensive gamble on an untested system designed by Navy construction workers who had no business redesigning armored warfare. Kissle kept working. By November 1944, all 8 tanks were complete. The Marine Corps designated them Mark Is. The Army's official designation was M4A3R5. The Marines who would eventually follow them into battle called them by a simpler name, Zippos, as in the cigarette lighter, as in something that produces fire reliably every single time. In early February 1945, the 8 tanks were loaded onto transport ships along with the Marine tank battalions assigned to Iwo Jima. Kissle and shipfitter first class Patterson were ordered to accompany them not as combatants technically, but as technical support. If something broke, they would fix it. If something failed, they would diagnose it. The fact that the island they were sailing toward was about to become one of the most violent places on Earth was apparently a secondary consideration. Kissle understood exactly what the order meant. He had built these machines. He knew every system, every weakness, every failure mode. He knew that no manual existed comprehensive enough to substitute for his own direct knowledge. If one of the Zippos broke during battle and he was 4,000 miles away in Hawaii, the repair would take days. Marines would die waiting. He boarded the transport ship with Patterson and did not look back. The 8 flame tanks landed on D-Day, February 19th. Marine commanders cautious about deploying an untested weapon system in the middle of an already chaotic assault held them back. For 2 days, the Zippos sat unused while Marines attacked fortified positions with conventional weapons and paid for it in blood. By February 21st, 4th Marine Division had a specific problem, a reinforced concrete pillbox concealed in volcanic rock, holding a Japanese Type 92 heavy machine gun that had already killed 11 Marines that morning. 2 days of attack, 15 total casualties. The position had not moved. A flame tank was requested. Kissle climbed into the assistant driver's position of the lead Sherman. His hands were steady. He had tested this exact mechanism 40 times. He knew what it was going to do. The tank moved out at 8 miles per hour across the black volcanic ash, and at 150 yards, Japanese machine gun fire began hitting the hull sharp metallic pings against steel plate. Each one a reminder of what the operators of portable flamethrowers had faced while standing in the open in the same fire, with no armor between them and the bullets. At 100 yards, the driver stopped and pivoted. Kissle aligned the nozzle. He checked the pressure gauge 300 pounds per square inch. He pressed the trigger. The ignition cylinder sparked. Pressurized fuel erupted through the nozzle. A stream of burning napalm arced 400 feet across the volcanic rock and poured directly through the pillbox's firing slit. 5 seconds. That was all it took. Smoke poured from every opening in the bunker. The Type 92 machine gun went silent. The position that had cost 15 Marine lives and 2 days of assault was neutralized before anyone outside the tank had time to process what they had just witnessed. Marines in covered positions who had watched 11 of their comrades die that morning began moving forward. A platoon leader radioed battalion headquarters and requested another flame tank immediately. Not one word about whether the system worked. It had obviously worked. The only question was how quickly they could get another one. Kissle climbed out of the Sherman at the rally point. Patterson checked the CBH-1 systems. No electrical failures. No fuel leaks. Pressure gauge within operational parameters. Every connection Kissle had soldered by hand at Schofield Barracks had held under combat conditions. The weapon performed exactly as designed. That afternoon, 3 more Zippos went into action. Each one destroyed multiple pillboxes and cave entrances. Not one flame tank was lost. Not one crew member was killed. By nightfall, Marine commanders were requesting flame tanks for every major assault on the island. The problem, and there was always a problem, was mathematics. 8 tanks, 4 per division, 750 Japanese fortifications. 11 miles of tunnels. And somewhere in the darkness of the island's tunnel network, Japanese commanders had already watched what happened to their pillbox at 7:45 that morning. They understood with absolute clarity what the Zippos meant. Orders were moving through the tunnels right now. Stop the flame tanks, target them first, kill the crews. The most dangerous weapon on Iwo Jima had just announced itself, and the men who built it, Kissle and Patterson, were sleeping that night on the island, surrounded by 22,000 soldiers who had just been ordered to destroy everything they had created. In Part 2, we will see what happens when the Japanese turn their full attention toward eliminating the Zippos, and whether 8 tanks and 2 Navy electricians can hold together long enough to change the course of the bloodiest battle in Marine Corps history. 8 flame tanks, 15 dead Marines, 5 seconds of fire. That is where Part 1 ended, with Joseph Kissle climbing out of a Sherman tank on Iwo Jima after his CBH-1 system destroyed in 5 seconds what an entire Marine division had failed to take in 2 days. The weapon worked. The math was undeniable. But on the night of February 21st, 1945, Japanese commanders inside 11 miles of tunnels had already issued new orders to every defender on the island: find the flame tanks. Target them first and destroy them before they destroy everything else. 22,000 soldiers now had a single priority, and Kissle was sleeping 50 yards from their tunnel entrances. Here is what most history books leave out. The Japanese response to the Zippos was not random. It was systematic, coordinated, and it nearly worked. February 22nd began before sunrise. At 0600 hours, Japanese mortar crews who had spent the night adjusting their range calculations opened fire on the fuel depot, where the flame tanks rearmed. The rounds walked in close, not direct hits, but close enough to scatter the crews and force the operation to halt for 40 minutes. Japanese forward observers had identified the resupply pattern from the previous day. They had marked the coordinates overnight. They were not guessing. They were hunting. Kissle and Patterson were already at work when the mortars hit. They had been up since 0400, moving between all 8 tanks in darkness, tightening electrical connections that had vibrated loose from the previous day's movement across volcanic rock. Every morning began this way. The CBH-1 was a precision instrument installed inside a machine that constantly traveled over broken terrain and absorbed enemy fire. Connections that held perfectly on a testing range at Schofield Barracks loosened after 6 hours of combat driving. Kissle carried a flashlight in his left hand and a soldering iron in his right, and he moved from tank to tank like a surgeon on a battlefield, finding failures before they became fatal. By noon on February 22nd, the 4 flame tanks assigned to 4th Marine Division had destroyed 18 fortified positions in 3 hours. The numbers arriving at battalion headquarters were almost impossible to process. Positions that had held for days, positions that had cost dozens of Marine casualties to neutralize through conventional assault, were being eliminated in 5-second bursts. A company commander radioed a report so terse it read more like disbelief than military communication position destroyed no casualties, requesting additional flame tank support immediately. The demand was already exceeding capacity. 8 tanks. Requests stacking up from 2 full Marine divisions. Every battalion that had watched a Zippo work wanted one of its own. The radio traffic became almost comical in its desperation units, competing with each other for access to 4 tanks per division, offering to trade artillery support, ammunition resupply, anything. One battalion operations officer reportedly told his counterpart, "Take your 75mm tanks and keep them. Send me 1 Zippo." But the Japanese were adapting. By February 23rd, anti-tank gun teams had been repositioned specifically to intercept flame tanks on approach routes. Japanese commanders understood the geometry of the problem. The CBH-1 had a maximum effective range of 400 feet, which meant a flame tank had to advance to within 400 feet of a fortified position to destroy it. That 400-foot approach was the kill zone. Station a 47mm anti-tank gun at 500 feet, and the flame tank had to survive direct fire before it could shoot back. 3 flame tanks took direct hits from anti-tank rounds on February 23rd. The Sherman's frontal armor held each time. The crews survived. The CBH-1 systems continued functioning. But Kissle, monitoring the damage reports, understood what the pattern meant. The Japanese were not firing randomly. They were targeting the same tanks, repeatedly probing for armor weaknesses, adjusting angles, searching for the shot that would penetrate. It was on February 27th that they came closest. Kissle was in the assistant driver's seat of a Sherman moving toward a fortified ridge in the northern sector when a Type 1 47mm anti-tank round struck the frontal armor at an oblique angle. The round did not penetrate. It deflected. But the impact threw Kissle sideways against the interior hull with enough force to dislocate his shoulder. The pain was immediate and total. Patterson was at the rally point. A Navy corpsman on the ground relocated the joint manually without anesthesia in approximately 4 minutes. Kissle was back inside a tank inspecting electrical systems within 2 hours. He did not report for evacuation. He did not request relief. The reason was straightforward. No one else on Iwo Jima fully understood the CBH-1's electrical architecture. Patterson understood the mechanical systems. Kissle understood the wiring. If Kissle left, and a critical electrical failure occurred in a flame tank during an assault, the repair would take days using documentation alone. Marines would wait. Missions would fail. People would die in the interval. That calculation was not complicated. He stayed. By March 1st, 10 days into continuous operations, the physical toll was becoming visible. Kissle was running on 3 to 4 hours of sleep per night. His dislocated shoulder caused constant pain that he managed by adjusting how he held his tools. His uniform was permanently soaked through with a combination of sweat, napalm fuel residue, and hydraulic fluid from the tank systems. His hands were cut in multiple places from the sharp metal edges inside tank interiors, and the cuts were not healing because they were reopened every time he worked. Patterson was in worse condition. On March 2nd, a Navy corpsman examined him and issued a direct order: 24 hours of rest, no exceptions. That left Kissle as the sole technician responsible for maintaining all 8 operational flame tanks. He worked through that entire day alone, moving between vehicles, running diagnostics, replacing ignition cylinders, tracing a corrosion fault in one tank's fuel pump line that had been causing intermittent pressure drops. He found the fault at approximately 2300 hours. He repaired it by 0100. The tank was operational by 0400 for its morning assignment. The battle's most severe test came on March 3rd. 5th Marine Division had been trying to take a sector the Marines called the Meat Grinder, 3 interlocking fortified hills designated Hill 362, Turkey Knob, and the Amphitheater. 9 days of assault, over 800 Marine casualties. Conventional attacks had failed repeatedly. The positions were too well integrated, the fields of fire too comprehensive. Artillery could not reach the interior bunkers without hitting Marine forward lines. Infantry assaults were being stopped within 50 yards of the perimeter every time. 4 flame tanks were assigned to support the assault on Hill 362. Kissle had spent 3 consecutive days rebuilding the electrical systems on the lead Sherman specifically for this mission. He accompanied it in the assistant driver's position. The tanks moved out at 0800. Japanese anti-tank fire opened immediately. One Sherman took 3 rounds on the turret within the first 60 seconds. The armor held. The tank did not stop. At 100 yards from the first fortified position on Hill 362, all 4 Zippos fired simultaneously. 1,600 feet of burning napalm hit the hillside at the same moment. Cave entrances became furnaces. Pillboxes burned from the inside out. Japanese defenders attempting to evacuate through tunnel exits found those exits already on fire. Secondary explosions erupted as stored ammunition cooked off from the heat, each one marking another position destroyed without a Marine having to advance into direct fire to reach it. The assault on Hill 362 lasted 12 minutes from first contact to secured position. 12 minutes. Against a fortified position that had held for 9 days and cost 800 casualties. Turkey Knob fell the same afternoon using identical tactics. The amphitheater required 2 more days, but the outcome was never genuinely in doubt once the flame tanks were committed. By March 5th, the entire meat grinder sector was secured. 5th Marine Division's after-action assessment credited the Zippos with saving an estimated 500 Marine lives in that sector alone. 500 people who were alive on March 5th because 8 tanks built by Navy construction workers at Schofield Barracks had worked exactly as designed under the worst possible conditions. The success generated an immediate problem. 3rd Marine Division, arriving as reinforcements, formally requested flame tank support for operations in the northern sector. The 8 original tanks were now running at 75% capacity. 2 had damaged fuel pumps. 1 had electrical failures that Kissle was managing through improvised repairs telephone wire, substituting for standard electrical cable in several circuits. Replacement parts fabricated from components salvaged off damaged conventional Shermans. The tanks were operational. Barely. A message went to Schofield Barracks, requesting additional flame tanks and trained technical personnel. Schofield Barracks was 4,000 miles away. Shipping time was measured in weeks. The battle would not wait weeks. Kissle understood the arithmetic exactly. Increasing demand, decreasing capacity. No reinforcements coming in time. The northern sector still held thousands of Japanese defenders in positions that conventional weapons could not neutralize. Every day without adequate flame tank support cost lives that the Zippos would have saved. And then, on the night of March 6th, Japanese commanders in the northern sector issued an order that would force those 8 deteriorating tanks and the 2 exhausted Navy electricians maintaining them into the most dangerous operation they had yet faced. A coordinated nighttime counterattack. 300 Japanese soldiers emerging from tunnel networks in total darkness, hitting Marine lines at 0200 in terrain where the flame tanks had never operated against an attack specifically designed to exploit every limitation the Zippos had shown during 2 weeks of combat. Kissle was going to have to take a flame tank into that darkness. And he already knew that 2 of the 8 vehicles had systems he did not fully trust. In Part 3, we will see what happens when the Zippos face their most dangerous night, and whether a weapon built for daylight assault can survive an enemy that has spent 16 days learning exactly how to kill it. 8 flame tanks, 240 missions, 370 fortified positions destroyed. That is where Part 2 ended, with Kissle and his deteriorating Zippos having survived the meat grinder, saved an estimated 500 Marine lives in a single sector, and facing a coordinated Japanese nighttime counterattack specifically designed to exploit every weakness the flame tanks had revealed over 16 days of combat. The enemy had been watching, learning, and now, in the darkness of March 7, 1945, they were coming. 300 Japanese soldiers. Tunnel exits in terrain the Zippos had never operated in. Total darkness. And 2 of the 8 flame tanks had electrical systems Kissle did not fully trust. This was no longer a test. This was survival. The counterattack began at 0200 hours. Japanese infantry emerged from tunnel exits across a 400-yard front near Kitano Point, moving fast through volcanic rock in darkness that made identification nearly impossible. Marine forward positions took the initial contact and held, but the pressure was building. Battalion commanders radioed for flame tank support within minutes of the assault beginning. The request created an immediate problem. Night operations for armored vehicles on Iwo Jima were not part of the original operational plan. The terrain was brutal in daylight, loose volcanic ash that shifted under tank treads, rock outcroppings that could high-center a Sherman shell craters that appeared without warning. In darkness, the risk multiplied, and Japanese infantry in the open at night, with magnetic satchel charges and no concern for their own survival, were exactly the threat that tank crews feared most. A man with a magnetic charge could approach an isolated tank in darkness, attach the device to the hull, and be 30 yards away before it detonated. Kissle climbed into the assistant driver's seat anyway. 2 flame tanks moved out at 0230 hours, guided by radio from forward observers, who could only estimate Japanese positions from muzzle flashes and the sound of movement. The Shermans advanced at 4 miles per hour slower than their daytime pace, the drivers navigating by the faint light of distant artillery flares. Kissle monitored the CBH-1 pressure gauge in near-total darkness, reading the needle by touch as much as sight. Wait! At 300 yards from the marine perimeter, the tank took fire from 3 directions simultaneously. Small arms rounds hit the hull in rapid sequence. Something heavy struck the turret, a satchel charge, that failed to detonate its magnetic clamp, scraping across steel before falling into the ash. The driver held course. Kissle felt the pressure gauge with his fingers. Still at 300 pounds per square inch. System intact. At 150 yards from the concentrated Japanese position, the gunner opened the CBH-1 trigger. Fire hit the night like a flashbulb. 400 feet of burning napalm swept across the hillside and illuminated everything. The volcanic rock. The tunnel exits the 300 soldiers who had assembled in darkness believing they were invisible. The flame found them all. The counterattack collapsed in under 4 minutes. The second flame tank arrived and secured the flanks. By 0300, the assault was broken. Marine lines held. Japanese soldiers caught in the open had no protection from liquid fire in an environment with no cover that napalm could not reach. Dawn revealed the cost to the attackers: 187 Japanese dead in the engagement zone. Marine casualties, 23. For a nighttime engagement of that scale and violence against a coordinated assault by trained soldiers, 23 casualties was a number that made experienced officers stop and reread the report. Night engagements on Iwo Jima had been producing casualty ratios that looked nothing like that. The Zippos had just proven something their designers had never specifically tested: they worked in darkness. But the night mission had extracted a price. Kissle spent the following 6 hours tracing electrical failures that had developed during the engagement corrosion, accelerated by salt air connections that had vibrated loose during the high-speed movement across rough terrain, a fuel line junction that had developed a hairline crack from the satchel charge impact. One tank's electrical system required a full rebuild using improvised materials. Patterson, still recovering from heat exhaustion, worked alongside him on the mechanical systems. By evening, 6 of the 8 tanks were operational. The other 2 were being held together with telephone wire and fabricated parts, and the specific knowledge in Kissle's memory that no technical manual could fully replicate. Wow, the enemy had learned something important from the counterattack's failure. Direct assault on marine lines, even at night, could not neutralize the flame tanks, because the flame tanks did not need daylight to function. Japanese commanders shifted their focus entirely. Anti-tank gun teams were repositioned to cover every approach route the Zippos had used. Fuel trucks supplying napalm mixture became primary targets. On March 10th, Japanese mortar fire destroyed 1 resupply vehicle and damaged 2 others, cutting daily fuel availability from 10,000 gallons to roughly 6,000. Each tank's mission allocation dropped from 6 operations per day to 3. Effectiveness decreased in direct proportion. The fuel crisis forced marine logistics officers to make choices they had not anticipated making. Which sectors got flame tank support and which did not? Which assaults were delayed waiting for a Zippo? Which battalion commanders were told their requests were denied because the napalm supply was exhausted for the day? Marines who had watched the flame tanks work did not accept those denials gracefully. Kissle heard, through the communication network that moves through any military unit faster than official channels, that at least 2 company commanders had refused direct orders to assault fortified positions without flame tank support. They were not wrong to refuse. They had seen the casualty numbers. They understood the arithmetic. But the arithmetic of supply was running in the wrong direction. It was during this supply crisis, March 11, 1945, 20 days into the battle, that the Zippos faced their most strategically significant single mission. The northern sector held a cave complex designated Target 7 in Marine operational maps. 3 interconnected caves in a volcanic ridge with tunnel connections to a larger network that extended nearly 200 yards into the rock. Japanese defenders inside had repelled 4 separate Marine assaults over 6 days. The position controlled the approach to the final Japanese defensive line in the north. Until Target 7 fell, the entire northern advance was stalled. Casualty count from previous assault attempts: 41 Marines dead, over 90 wounded. 3 flame tanks were assigned. Kissle rode in the lead vehicle. The approach took 19 minutes across terrain that had been fought over for 3 weeks and showed its shell craters, burned equipment, the wreckage of vehicles from both sides. Japanese anti-tank gunners opened fire at 200 yards. 2 rounds hit the lead Sherman on the frontal plate. The armor held. The tank moved forward. At 80 yards, the range was close enough that Kissle could see the primary cave entrance through the periscope without magnification. A machine gun barrel was visible in the opening. The gunner lined up the CBH-1 nozzle. First burst. 5 seconds. Burning napalm filled the primary entrance completely. The gunner shifted left. Second burst. The secondary cave entrance became a furnace. Third position. Third burst. 5 seconds. The interconnected tunnel network turned the flame into a weapon the cave's designers had never anticipated. Napalm that entered one opening found its way through connecting passages into spaces that could not be reached from outside. Secondary explosions began within 40 seconds, stored ammunition, fuel supplies, materials that the Japanese defenders had positioned for a long siege. Each explosion shook the ground under the Sherman's treads. Black smoke began pouring from tunnel exits 100 yards behind the main position, marking passages the Marines had not known existed. The entire engagement from first trigger pull to silence took 11 minutes. Marines advanced and found no resistance. The 41 men who had died in 6 previous assault attempts had faced a position that 11 minutes of flame had rendered completely indefensible. A Marine sergeant, who was among the first to enter the cleared area after the smoke settled later, described what he found as simply nothing left to fight. That report traveled up the chain of command faster than standard communication protocol. By evening, General Cates at 4th Marine Division had seen the Target 7 assessment. By the following morning, the language in Marine Corps official communications about flame tanks had changed in a way that anyone who reads military documents can immediately recognize, from cautious endorsement to unqualified priority. The impact was measurable within days. Sectors operating with flame tank support were advancing at 3 times the rate of sectors without. Casualty rates in supported sectors ran 42% below the campaign average. Japanese defenders who had held positions for a week under conventional assault were abandoning them within hours of flame tanks appearing on approach routes. The psychological effect had become as significant as the physical one. The sound of Sherman engines and the smell of napalm were producing retreats that artillery barrages had failed to generate. By March 20th, the operational statistics were comprehensive enough to be definitive. 240 missions. 370 fortified positions destroyed. 140,000 gallons of napalm consumed. 0 flame tanks lost to enemy action. Crew casualties at 12% compared to 92% for portable flamethrower operators in the same battle. 5th Marine Division's formal assessment used the word decisive. 4th Marine Division's after-action report called the flame tank the most valuable single weapon on the island. The 23rd Regimental Combat Team recommended increasing the flame tank allocation from 4 per division to 8 as minimum standard. One Marine platoon leader wrote an assessment so direct it required no interpretation. The infantry would sooner see 1 flamethrower tank than a dozen conventional Shermans with 75mm guns. That sentence, written in a field report on a volcanic island in March 1945, became Marine Corps doctrine within 60 days. The entire 713th Tank Battalion converted to flame configuration before the Okinawa landing on April 1st. 54 tanks, all running systems, derived from Kissle's CBH-1 design. On Okinawa, operating for 82 days, they consumed 200,000 gallons of napalm and produced results that Army commanders described in terms usually reserved for weapons of significantly greater complexity and cost. Japanese defenders abandoned fortified positions when flame tanks appeared on the horizon. The weapon built by a Navy electrician at Schofield Barracks had fundamentally altered the calculus of Pacific assault operations. Kissle himself received Navy commendation for his work on Iwo Jima. The citation described his technical contributions and his refusal to evacuate despite injuries. It used the language that military commendations use, measured formal specific about actions and outcomes. It did not and could not fully describe what those 32 days actually cost him, or what he thought about in the years after when he considered what he had built and what it had done and how many men were alive in 1946 because of decisions he had made in a machine shop in Hawaii in the autumn of 1944. That is Part 4's story, and because the weapon outlasted the battle that proved it. The CBH-1 system remained in American service until 1955. It was used in Korea. It influenced mechanized warfare doctrine across 2 decades. And the man who wired every circuit by hand, who tested every connection 40 times, who refused evacuation with a dislocated shoulder on a burning island, returned to civilian life and lived the rest of his years as something the history books almost never find room for. The question of what a man carries home from something like Iwo Jima, and what a society owes the people who build the weapons that win its wars, that chapter of the story is the one most people never hear, and it may be the most important one of all. From a machine shop in Hawaii to the bloodiest 8 square miles in Marine Corps history, from a design that Army engineers called dangerously absurd to the most effective single weapon on Iwo Jima. From a 24-year-old Navy electrician nobody outside the 117th Construction Battalion had ever heard of, to the man whose wiring kept 8 flame tanks operational through 36 days of combat that killed 6,821 Americans and broke the back of Japanese Pacific defense. That is where Part 3 ended, with Kissle's CBH-1 system proven adopted and expanded to 54 tanks for Okinawa, with the Marine Corps calling it decisive, with a commendation citation describing his actions in the careful, measured language that military documents use when they are trying to contain something that does not fit neatly into standard categories. But the citation did not answer the question that matters most. What happened to the man himself? And because success in war has a cost that the after-action reports do not track. Joseph Kissle left Iwo Jima on March 23, 1945, 32 days after he had climbed into a Sherman tank with a weapon he had built himself to find out if it worked. He returned to Schofield Barracks in Hawaii, where the CBH-1 project had begun in that classified machine shop 9 months earlier. The workbenches were still there. The tools were still there. The documentation he had written for the systems he understood better than anyone else alive was still filed in the same cabinets. He was 24 years old, and his shoulder had not fully healed, and he had not slept more than 4 consecutive hours at any point in the previous 5 weeks. The Navy processed his paperwork with the efficiency that military bureaucracies apply uniformly to heroes and to everyone else. He received his Navy commendation. He was promoted. The citation used phrases like exceptional technical proficiency and meritorious service under fire and refused evacuation despite injury. All of those phrases were accurate. None of them described what it had actually been like to be inside a tank on a volcanic island, while 22,000 soldiers who had been ordered to kill you specifically were working through the night to figure out how to do it. And Patterson received similar recognition. The 2 men who had maintained 8 flame tanks through the entirety of the battle, who had improvised repairs with telephone wire and fabricated parts, and the specific irreplaceable knowledge that lived in their own memories, were processed through the same system that processed everyone else. They were thanked. They were decorated. They were returned to their units. When the war ended in September 1945, Kissle was discharged and returned to civilian life. He went home. He found work as an electrician, which was what he had been before the war and what his skills made him naturally after it. He did not become famous. He did not write a memoir. He did not lecture at military academies or consult for defense contractors or appear in the newsreels that celebrated the men whose names became attached to the victory. He became one of the several million Americans who built things during the war that helped win it, and then came home and built other things and lived their lives with the specific weight of having been somewhere that most people would never go and having done something that most people would never fully understand. There is a moment that deserves to be named directly. Somewhere in the years after 1945, Joseph Kissle would have read or heard the final casualty figures from Iwo Jima. 6,821 Americans killed. Over 26,000 total casualties. The only battle in the Pacific War where American casualties exceeded Japanese. And somewhere in those numbers, he would have understood in the way that only the people who were actually there can understand how many of those Marines came home, because 8 tanks stayed operational for 36 days. How many families received their fathers and sons and brothers back because the electrical connections held, because the ignition cylinders were replaced on time, because one electrician's mate second class refused to get on a hospital ship with a dislocated shoulder. That knowledge is not a small thing to carry. But the legacy he left was not confined to what he personally witnessed. It was already moving outward from Iwo Jima before he left the island, spreading through the military bureaucracy with the speed that genuinely decisive weapons always travel through institutional systems once the results become undeniable. The numbers that came out of Iwo Jima were comprehensive and unambiguous. 8 tanks, 240 missions, 370 fortified positions destroyed, crew casualties at 12% versus 92% for portable flamethrower operators, infantry casualty rates 42% lower in sectors with flame tank support, Marine commanders from 3 separate divisions filing independent assessments that used the same essential conclusion: this weapon changed what was possible. The Marine Corps did not hesitate. By April 1, 1945, when American forces landed on Okinawa, the entire 713th Tank Battalion had converted to flame configuration, 54 tanks, all running CBH-1, derived systems trained by Seabees from Schofield Barracks who had worked directly under Kissle and Patterson. On Okinawa, those 54 tanks operated for 82 days. They consumed 200,000 gallons of napalm. They destroyed fortified positions across terrain even more complex than Iwo Jima. Army commanders filing assessments after Okinawa used language that had by that point become standard. The flame tanks had a psychological effect on enemy defenders that conventional armor could not replicate. Japanese soldiers who had demonstrated willingness to die in place against artillery and infantry assault were abandoning positions when flame tanks appeared on approach routes. Sherman. The CBH-1 system remained in American military service until 1955, 11 years after Kissle first installed it in a Sherman hull at Schofield Barracks. It served in Korea from 1950 to 1953, where the terrain and the fortification patterns of the conflict made it precisely as relevant as it had been in the Pacific. American forces using flame tanks in Korea reported results that tracked almost exactly with the Iwo Jima data: faster position reduction, lower crew casualties, measurable psychological impact on defenders. The system that a 24-year-old Navy electrician wired by hand influenced mechanized warfare doctrine across 2 decades and 2 major conflicts. The nations that studied American Pacific campaign records after the war absorbed the flame tank lesson with considerable attention. The Soviet Union, which had been developing its own armored flame systems through the war, reviewed the CBH-1 specifications as part of post-war intelligence assessment. British military planners incorporated flame tank doctrine into their own armored vehicle development programs. The principle that Kissle had applied: remove the operator from exposure range, extend the weapon's reach through mechanical means, protect the crew with armor that a human body cannot provide, became foundational to how multiple militaries thought about the problem of fortified position reduction for a generation. The lesson was not complicated. It was not even new in its basic form. But the specific execution, the particular combination of pressure fuel capacity, ignition, reliability, and electrical architecture that Kissle built into the CBH-1 was precise enough and proven enough that it became the template, not a starting point for further development. The template. The thing other systems were measured against. That matters because the pattern it represents appears throughout military history with remarkable consistency. The innovation that changes a conflict rarely comes from the official development program with the largest budget and the most credentialed engineers. It comes from someone who is close enough to the actual problem to feel its weight and who has the specific practical skills to build a solution, and who cares enough about the outcome, enough about the men dying from the problem, to keep working when the institution tells them to stop. The Wright brothers were bicycle mechanics. The engineers who developed radar in Britain operated initially with almost no institutional support and considerable official skepticism. The soldiers who first improvised effective counter-IED tactics in Iraq and Afghanistan in the early 2000s were junior enlisted men solving immediate problems with available materials, not defense contractors with development contracts. The pattern is so consistent across military history that it should probably be taught as a principle rather than a series of isolated anecdotes. Kissle was a CB, a construction worker in uniform, who understood electricity well enough to design a combat system from functional components, who understood the problem well enough to know what the system needed to do, and who cared enough about the Marines who would follow his tanks, that he refused evacuation with a dislocated shoulder on a burning island because no one else fully understood the wiring. That combination of technical skill, proximity to the problem, and personal investment in the outcome produced something that the Army's official tank development program had attempted and failed at. The Satan tank existed before the CBH-1. It was inadequate. Kissle's version was not. Now for the detail that most accounts of Iwo Jima's flame tanks leave out entirely. The 8 M4A3 Shermans that Kissle and his team converted at Schofield Barracks were not purpose-built for the CBH-1 system. They were standard combat tanks that had been requisitioned from Army inventory. The conversion work, 150 pounds of welding rod, over 1,000 individual electrical connections. The complete integration of a pressurized fuel delivery system into a vehicle designed for something else entirely was done in approximately 3 months by a composite unit that had never attempted anything similar before. Once, when those tanks arrived on Iwo Jima, they were officially classified as support equipment attached to Marine tank battalions. They were not given their own operational designation in the initial landing orders. They were not included in the primary assault plan. They sat unused for 2 full days while Marine commanders cautiously evaluated whether an untested system should be committed to a battle that was already going badly. The weapon that Marine Corps after-action reports would later call the most valuable single weapon on the island spent the first 48 hours of the battle parked at the beach. It required a specific request from a specific 4th Marine Division unit facing a specific pillbox that had killed 15 men over 2 days before anyone in the command structure authorized the first Zippo mission. 1 request, 1 pillbox, 5 seconds of fire. And then everything changed. That sequence, the untested weapon sitting unused while men die in the gap, it could fill the hesitation of institutions trained to trust what has been proven over what has merely been built and tested is not unique to Iwo Jima. It appears in every conflict where innovation matters. The institution's caution is understandable. Untested weapons fail. Failed weapons cost lives. But the caution also has a cost, and on Iwo Jima. That cost was measured in the 15 Marines who died at the pillbox that a Zippo destroyed in 5 seconds on February 21st. The men who built the CBH-1 understood this. Kissle understood it when he climbed into the assistant driver's seat on that first mission, not because anyone ordered him into combat, but because he knew the weapon and trusted it, and understood that its first failure in the field could end the entire program. He had tested the ignition system 40 times. He needed it to work once publicly in front of everyone who had doubted it, with Marines watching from covered positions and Japanese machine gun fire hitting the hull. It worked. The ignition cylinder sparked, the napalm ignited, the pillbox burned. From one Navy electrician with an idea that Army engineers called dangerously absurd to a weapon system that served in 2 wars across 11 years and influenced armored warfare doctrine on multiple continents. The CBH-1 destroyed 370 fortified positions, reduced crew casualties by 80% compared to portable flamethrowers, saved an estimated several thousand Marine lives across Iwo Jima and Okinawa alone, and remained the primary American flame tank system for more than a decade, after the man who built it came home and went back to work as an electrician. Joseph Kissle proved something that military history keeps proving, and institutions keep forgetting: the most important innovations in warfare do not always come from the largest programs or the most credentialed designers. Sometimes they come from a 24-year-old with a soldering iron who is close enough to the problem to understand exactly what needs to be built, and stubborn enough to build it even when everyone with more rank and more credentials tells him it cannot be done. If this story moved you, share it. Leave a comment about a family member who served in the Pacific in Europe on the home front. These stories survive because people carry them forward. Subscribe for more accounts of the ordinary people who changed extraordinary moments in history. There are hundreds of them, and most have never been told to an audience that deserves to hear them. The measure of a weapon is not its complexity. The measure of a weapon is whether the men who depend on it come home. By that measure, what Joseph Kissle built in a machine shop in Hawaii in the autumn of 1944 was among the finest weapons of the Second World War, because the men who followed it into battle came home, and the men who built it made sure of that with their own hands. Asterisk.